Hello, in this lecture we will find out the area of quadrilateral ABCD using two different methods. In the drawing we have quadrilateral ABCD. We know that side AB equals to 4 units, side CD equals to 2 units. We also know that CB equals to DA and angle BAD, this angle equals to 30 degrees, while angle ABC is a right angle, it equals to 90 degrees, and we want to find out the area of this quadrilateral ABCD. So we'll start with the first method. In the first method, we will do a construction from point D. We will draw perpendicular to side AB. So this angle will be a right angle, it will be equal to 90 degrees, and this angle will be also a right angle, that is to say it will be equal to 90 degrees. We will define the touching point between the perpendicular from point D and AB as point E. And we will focus on the right triangle ADE. But first of all, we will define line segment DE as A, that is to say the length of line segment DE is equal to A units. Then we will focus on the right triangle ADE. On the right triangle ADE, we know that sinus 30 degrees equals to DE over AD. I'll repeat again. In the right triangle ADE, we know that sinus 30 degrees equals to DE over AD, but DE equals to A according to our definition. So we can write down that it equals to A over AD, and we also know that sinus 30 degrees is equal to 1 over 2, so 1 over 2 equals to A over AD. So here we will cross multiply equation number 1 and we will get that AD equals to 2 times A. AD equals to 2A. So I can write here that AD equals to 2A But because of the fact, according to what is given us in the question, we know that AD equals to CB. CB equals to AD. It is given us in the question that AD equals to CB. And we found out that AD equals to 2A. So from this equation, we'll conclude that CB also equals to 2A. CB equals to 2A. So we can write here that the length of CB is 2A. Okay, here the length of side CB is 2A. In the next step, from point D, we will draw perpendicular to CB. I will repeat again, we will draw perpendicular from point D to side CB. So actually, this angle will be a right angle, and this angle will be a right angle, which is associated with equal to 90 degrees. We will define the touching point between the perpendicular from point D and CB as point F. So actually, in quadrilateral DFEB, this quadrilateral, we have three right angles. 1, 2, 3. We will define angle EDF. This angle is angle X. I will present to you the first rule, rule number 1. According to rule number 1, the sum of the angles in any quadrilateral is equal to 360 degrees. We will read rule number 1 again. According to rule number 1, the sum of the angles in any quadrilateral is equal to 360 degrees. So actually, rule number 1 is true, especially in quadrilateral DFEB. The sum of the angles in quadrilateral DFEB is equal to 360 degrees according to rule number 1. So the sum of the angles in quadrilateral DFEB will be equal to 360 we have three right angles, 1, 2, 3. The sum of three right angles is 90 times 3 is 270 degrees. Plus the size of the fourth angle, that is actually angle X. So the sum of all four angles in quadrilateral DFEB must be equal to 360 degrees according to rule number 1. So here we will subtract 270 degrees from this equation, and we will get that the value of angle X equals to 360 degrees minus 270 degrees is actually 90 degrees. So we found out that angle X is a right angle, that is to say it equals to 90 degrees. So we can change angle X to a right angle as you can see. In quadrilateral DFEB we have four right angles, and we have rule number 2. According to rule number 2, any quadrilateral that has four right angles must be at least a rectangle if not a square. So if not a square, it must be a rectangle. So I will read rule number 2 again. According to rule number 2, any quadrilateral that has four right angles must be at least a rectangle, if not a square. And because of the fact that quadrilateral DFEB has four right angles, quadrilateral DFEB is a rectangle according to rule number 2. Quadrilateral DFEB is a rectangle according to rule number 2. So we will relate to quadrilateral DFAB as a rectangle. And we have also rule number 3. According to rule number 3, the opposite sides of a rectangle are equal to each other. The opposite sides of a rectangle equal to each other. So I will read rule number 3 again. According to rule number 3, the opposite sides of a rectangle are equal to each other. So the opposite sides of rectangle DFEB, they are equal to each other. It means that DE equals to FB. Rectangle DFEB DE equals to FB according to rule number 3. But according to our definition, DE equals to A. DE equals to A. And from this equation, we will derive that FB also equals to A. FB equals to A. So we can write here that FB equals to A. What is the value of CF? The value of CF, you can see it from the drawing that CF equals to CB minus FB. CB minus FB equals to CF. That is to say, CF equals to CB, that is 2A, minus FB, that is A. So CF equals to 2A minus A, that is to say it equals to A. So we found out that CF equals to A. CF equals to A, we can write here that CF equals to A. In the next step, we'll join together points D and B by a straight line. And we will prove the triangle DCF can point to triangle DFB. I'll repeat again. We will prove that this triangle DCF, the right triangle, can point to this triangle DFB. So why those two triangles can point to each other? First of all, we know that CF equals to FB equals to A. I'll repeat again. CF equals to FB equals to A. We also know that those two angles, they are equal to each other, they are both right angles. So angle CFD, this angle, is equal to this angle that is actually angle BFD. And those two angles, they're both equal to 90 degrees. So angle CFD equals to angle BFD equals to 90 degrees. and we also have a common side. FD is a common side, it belongs to both triangles, so we can write down that FD equals to FD equals to itself. FD equals to FD is a common side that belongs to both triangles. I will repeat again. FD equals to FD is a common side that belongs to both triangles. So we actually proved that triangle DCF congruent, this is the sign of congruent to triangle DFB according to side angle side rule. I'll repeat again. We prove the triangle DCF congruent to triangle DFB according to side angle side rule. So what is side angle side rule? Side angle side rule is that if you prove that two sides and the angle between those two sides in one triangle congruent to two sides and the angle between those two sides in another triangle, you actually proved that those two triangles congruent to each other according to side angle side rule. And we actually proved that those two sides, that is to say CF and DF, and the angle between them, that is to say this right angle, in triangle CFD congruent to those two sides and the angle between them in triangle DFB. Therefore, we prove that those two triangles congruent to each other according to side angle side rule. From the fact that those two triangles congruent to each other, we will conclude that DC equals to DB. DC equals to DB. We will conclude that DC equals to DB according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles congruent to each other, therefore the corresponding sides, that is to say CD and DB, will be equal to each other. But it is given us in the question that CD equals to 2 units. So you can write here that CD of DC equals to 2 units. And from this equation, we will conclude that dB also equals to 2 units. dB equals to 2 units. We can write here that dB equals to 2 units. In the next step, I will present to you a new law or new rule or new law that is actually the law of cosines. According to the law of cosines, First of all, the law of cosines is true in any triangle. So we can write down that in any triangle, you can use it in any triangle. In any triangle, so actually if we have triangle ABC, that could be any triangle. This is triangle ABC, that could be any triangle. We know that side AB of triangle ABC equals to A units in its length. Side BC of this triangle equals to B units in its length. And side AC equals to C units in its length. And we also know that the angle between AB and the BC is angle theta. Then, according to the law of cosines, A squared plus B squared minus 2 times AB cosine theta equals to C squared. Here we will subtract C squared and also add 2AB cosine theta to this equation. And we will get that A squared plus B squared minus C squared equals to 2 times AB cosine theta. Here we will divide this equation by 2 times AB, and we will get that cosine theta equals to A squared plus B squared minus C squared over 2 times AB. I repeat again, in any triangle, cosine theta equals to A squared plus B squared minus C squared over 2 times AB. So we actually can implement the law of cosines in our triangle ADB, this triangle ADB. So I will copy triangle ADB in a new page, and we will implement the law of cosines on this triangle. Okay, so we have triangle ADB. So actually this is triangle ADB. We will implement the law of cosines in this triangle ADB. according to the law of cosines, cosine 30 degrees cosine 30 degrees will be equal to 2a squared plus 4 squared minus 2 squared over 2 times 2a times 4. Okay, so this equation is the implementation of the law of cosines in our triangle ADB. We know that cosine 30 degrees is square root of 3 over 2, and it equals to 2a squared is 4a squared plus 4 squared is 16 minus 2 squared is minus 4, 16 minus 4 is 12 over 2 times 4 is 8, and 8 times 2a is 16a. Here we will multiply this equation by 16a, and we will get that square root of 3 over 2 times 16a equals to 4a squared plus 12. So here 16 over 2 is 8. So we get here 8 times square root of 3a equals to 4a squared plus 12. So here we will divide this equation by 4, and we will get that 8 over 4 is 2. So we get here 2 times square root of 3 times a equals to 4 over 4 is 1. So here we will have a squared plus 12 over 4 is 3. So in conclusion, so we got that 2 times square root of 3a equals to a squared plus 3. Here we will subtract of this equation 2 times square root of 3a, and we will get that a squared plus 3 minus 2 times square root of 3 times a equals to 0. I'll repeat again. We got that a squared plus 3 minus 2 times square root of 3a equals to 0. We know that 3 is actually square root of 3 squared. So we will substitute 3 by square root of 3 squared. And we will get that a squared plus square root of 3 squared minus 2 times a times square root of 3 equals to 0. So this equation is very similar to the algebraic identity that a squared plus b squared minus 2 times a b equals to a minus b square that equals to 0. So according to this algebraic identity, we will get that we can substitute this expression by a minus b square. In our specific equation, this equation a equals to a and b equals to the square root of 3. So a minus b square, it is actually a minus square root of 3 square that equals to 0. So we got that a minus square root of 3 square equals to 0. We will take a root out of this equation and we will get that a minus square root of 3 equals to 0 because of the fact that the square root of 0 is 0. We will add to this equation square root of 3 and we will get that a equals to square root of 3 units. We found out that a equals to square root of 3 units, so we can write here that a equals to square root of 3 units, and also here a equals to square root of 3 units, and also here a equals to square root of 3 units. And in the next step we will focus on the right triangle, triangle DEB. On the right triangle, triangle DEB, we will implement the Pythagoras theorem on the right triangle, triangle DEB. Okay, we will implement the Pythagoras theorem. PT is abbreviation for Pythagoras theorem on the right triangle, triangle DEB. So on the right triangle, triangle DEB, we will get that DE square plus EB square equals to DB square I will repeat again, according to equation number 1, in the right triangle, triangle DEB, the square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say, DE square plus EB square equals to DB square. We found out that DE equals to A that equals to square root of 3. Square root of 3 square is 3 plus EB square. EB is the missing variable, so we will leave it as it is, plus EB square equals to DB square. DB equals to 2 units, therefore DB square is 2 square, 2 square is 4. Here we will subtract 3 from this equation, equation number 1, and we will get that EB square equals to 4 minus 3. 4 minus 3 is 1. Here we will take a root out of this equation, equation number 1, and we will get that EB equals to the square root of 1. The square root of 1 is 1. So we found out that EB equals to 1. So we can write here that EB equals to 1 unit, and because of the fact that according to rule number 3, the opposite sides of a rectangle are equal to each other. That is to say, the opposite sides of rectangle DFEB are equal to each other. It means that EB equals to DF, but EB equals to 1 unit, therefore DF will be also equal to 1 unit. And what is the value of AE? The value of AE, it is actually AB minus EB. Again, AB minus EB equals to AE. So I will write it down. AB minus EB equals to AE. So AE equals to AB, that is 4 units, minus EB, that is 1 unit. 4 minus 1 is 3, so we found out that AE equals to 3 units. AE equals to 3 units, so we can write here that AE equals to 3 units. Now we can easily find out the area of quadrilateral ABCD because of the fact the area of quadrilateral ABCD will be equal to the area of the right triangle ADE plus the area of quadrilateral DFEB plus the area of the right triangle CFD. So I write it down. The area of quadrilateral ABCD here the squared brackets is the sign for the area. It means the area of triangle the area of quadrilateral ABCD will be equal to the area of the right triangle ADE, this triangle, plus the area of rectangle DFEB plus the area of the right triangle CDF. I will repeat again. The area of quadrilateral ABCD equals to the area of the right triangle ADE plus the area of rectangle DFEB plus the area of the right triangle CDF. What is the area of triangle ADE? The area of triangle ADE equals to the base of the triangle, that is AE, times the height to the base, that is DE, over 2. So the area of triangle ADE is AE times DE over 2. And the area of rectangle DFEB, this rectangle, is equal to the width of the rectangle times the length of the rectangle. The width of the rectangle is EB, and the length of this rectangle is FB. So it is EB times FB plus the area of the right triangle CFD. The area of the right triangle, triangle CFD, is equal to the base of the triangle, that is actually DF, times the height to the base, that is actually CF, over 2. Okay, and here, so the area of triangle ADE is AE. AE equals to 3 units times DE. DE equals to square root of 3 units. That is A over 2. So we found out that the area of the right triangle, triangle ADE, equals to 3 times square root of 3 over 2. And the area of rectangle DFEB equals to EB. EB is 1 plus FB. FB is square root of 3 units. So the area of rectangle DFEB is square root of 3 units. Square root of 3 square units plus the area of the right triangle CDF. The area of the right triangle CDF is DF times CF. DF is 1. CF is square root of 3, all divided by 2. So here we will multiply square root of 3 by 2, and then we will divide it by 2 in order to have a common factor with the other two expressions. And we will take a common factor square root of 3 out of those 3 expressions, and we will get that square root of 3 is a common factor. So inside the brackets we will have here, from this expression, what is left is only 3. From this expression, what is left after we took common factor square root of 3, what is left, it is actually 2. And what is left from this expression after we took from it square root of 3 as a common factor, what is left, it is actually 1. And all divided by 2. So here we have square root of 3. 3 plus 2 is 5. 5 plus 1 is 6. All divided by 2. 6 over 2 is 3. So it is 3 times square root of 3. So we actually found out that the area of triangle A, the area of quadrilateral ABCD equals to either 3 times square root of 3 square units, or in terms of numbers, it equals to 5.196 square units. Okay? Repeat again, the area of quadrilateral ABCD equals to either 3 times square root of 3 square units, or in terms of numbers, it equals to 5.196 square units. So we finished with the first method. In the next step, I will present to you how to find out the area of this quadrilateral ABCD using the second method. In the second method, we will do another construction from point C. We will draw perpendicular to CB. Therefore, this angle will be a right angle, that is to say it will be equal to 90 degrees. And then from point A, we will draw perpendicular to AB. So this angle will be a right angle, that is to say it will be equal to 90 degrees. We will define the intersection point between the perpendicular from A and the perpendicular from C as point E. So this point is defined as point E. Actually, by doing this construction, we created quadrilateral ABCE, and in quadrilateral ABCE we have three right angles, 1, 2, 3, and the sum of three right angles is 90 times 3 is 270 degrees, plus the size of this angle, angle AEC, that we will define as angle X. The sum of those four angles in quadrilateral ABCE must be equal to 360 degrees according to rule number 1. I will repeat again. According to rule number 1, the sum of the angles in quadrilateral ABCE equals to 360 degrees. That is to say, the sum of the three angles, that is 270 degrees, plus the size of the fourth angle. In total, they must be equal to 360 degrees. We will subtract 270 degrees from this equation, and we will get that angle X equals to 360 degrees minus 270 degrees is actually 90 degrees. So we found out that angle X is a right angle. That is to say it equals to 90 degrees. So we'll change angle X to a right angle. So you can see from the drawing that all four angles in quadrilateral ABCE are right angles. They are equal to 90 degrees. And we have also rule number 2, that any quadrilateral that has four right angles must be at least a left angle. So we relate to quadrilateral ABCE as a left angle. This is according to rule number 2. Quadrilateral ABCE is a rectangle. And according to rule number 3, the opposite sides of a rectangle are equal to each other. That is to say, in rectangle ABCE, AB equals to EC. In rectangle ABCE, AB equals to CE according to rule number 3. AB equals to CE according to rule number 3, that the opposite sides of a rectangle are equal to each other. But it is given us the question that AB equals to 4 units. AB equals to 4 units. From this equation, we will derive that CE also equals to 4 units. So we can write here that CE or EC, it is the same. It equals to 4 units. Likewise, according to rule number 3, CB equals to AE. According to rule number 3, CB equals to AE. And if we define CB as X, then AE will be also equal to X. Here AE equals to CB equals to X. So CB equals to AE equals to X. Both those two sides are equal to X. But according to what is given us in the question, we know that CB equals to AD. It is given us in the question that CB equals to AD. But CB equals to X. According to our definition, CB equals to X. From this equation, we will derive that AD also equals to X. AD equals to X. Here AD equals to X. In the next step, we will connect together, we will join together points E and D by a straight line. And we will join together points D and B by a straight line. Here we know that angle AEB equals to 90 degrees because we built it like that. Angle DAB equals to 30 degrees. So if we subtract 30 degrees from this angle that equals to 90 degrees, we will get the value of angle EAD. It will be equal to 90 degrees minus 30 degrees, that is to say this angle equals to 60 degrees. Okay, so in the next step, I will copy triangle AED in a new page and we will analyze triangle AED. Okay, so I will copy triangle AED in a new page. Triangle AED is two sides that are equal to each other, and we also know that angle EAD equals to 60 degrees. So this is triangle AED. We know that AE equals to AD equals to X. We have the rule that in front of equal sides in the triangle there are equal angles. So those two sides, they are equal to each other. Therefore, in front of these two sides we have equal angles. That is to say, those two angles that are located in front, those two equal sides must be equal to each other. So if we define angle AED as y, that angle EDA will be also equal to y. And we know that the sum of the angles in any triangle is equal to 180 degrees. The sum of the angles in triangle AD must be equal to 180 degrees. That is to say, y plus y plus this angle that is equal to 60 degrees must be equal to 180 degrees. We will subtract 60 degrees from this equation, and we will get that 180 degrees minus 60 degrees is 120 degrees. Y plus y is 2y, so we found out that 2y equals to 120 degrees. We will divide this equation by 2 and we will get that angle y equals to 60 degrees. So we found out that angle y equals to 60 degrees. We will substitute y by 60 degrees. You can see from the drawing that triangle AED is an equilateral triangle. Triangle AED is an equilateral triangle that is to say, all of its sides are equal to each other. If AE equals to x, then ED will be also equal to x, and all of its angles, they are equal to 60 degrees. So in the original drawing, we can write down that ED equals to x, angle AED equals to 60 degrees, and angle ADE also equals to 60 degrees. We know that angle AEC is a right angle, that is to say it equals to 90 degrees, while angle AED equals to 60 degrees. So 90 degrees minus 60 degrees will be the value of this angle, angle DEC. That is to say the value of angle DEC equals to 30 degrees. Angle CED equals to 30 degrees. In the next step, we will prove that those two triangles can go into each other. That is to say, triangle ADB, this triangle, can go to triangle EDC, this triangle. So why those two triangles can go into each other? First of all, we know that AB equals to EC equals to 4 units. I will repeat again. AB equals to EC equals to 4 units. We just right now found out that those two angles, they are equal to each other. They are both equal to 30 degrees. So we can write down that angle BAD is equal to angle DEC, and they are both equal to 30 degrees. I'll repeat again. Angle BAD equals to angle DEC equals to 30 degrees. And AD equals to ED equals to X. AD equals to ED equals to X. I'll repeat again. AD equals to ED equals to X. So we actually proved that triangle ADB congruent to triangle EDC according to side angle side rule. I will repeat again. We proved the triangle ADB congruent to triangle EDC according to side angle side rule. And from the fact that those two triangles congruent to each other, we will conclude that DC equals to DB. DC equals to DB. DC equals to DB according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles congruent to each other, therefore the corresponding sides, that is to say CD and DB, will be also equal to each other. But we know that DC equals to 2 units. It is given us in the question. We can write here that DC equals to 2 units because it is given us in the question. From this equation, we will derive that dB also equals to 2 units. dB equals to 2 units. Here, dB equals to 2 units. And in the next step, we will implement the law of cosines in this triangle ADB. Okay, so I will copy this triangle to a new page and we will implement the law of cosines on this triangle. So we have triangle ADB. So this is triangle ADB. We will implement the law of cosines on this triangle ADB. According to the law of cosines, we will get that cosine 30 degrees equals to x squared plus 4 squared minus 2 squared over 2 times x times 4 cosine 30 degrees is square root of 3 over 2 and it equals to x squared. 4 squared is 16 minus 2 squared is minus 4. 16 minus 4 is 12 over 2 times 4 is 8. 8 times x is 8x. We will multiply this equation by 8x, and we will get that square root of 3 over 2 times 8x equals to x squared plus 12. 8 over 2 is 4, so I'll write it down. We will get here 4 times square root of 3 times x equals to x squared plus 12. We will subtract 4 times square root of 3x from this equation, and we will get that x squared plus 12 minus 4 times square root of 3 times x equals to 0. Here we will substitute 12 by 2 times square root of 3 square. 2 times square root of 3 square equals to 12, so we can substitute 12 by it. And we will get that x squared plus 2 times square root of 3 squared that equals to 12 minus, here we will substitute minus 4 by 2 times minus 2 times minus 2 minus 2 times 2, so it will be 2 times x times 2 times square root of 3 that equals to 0. So we got this expression. Actually, this expression is very similar to the following expression. It is actually very similar to the algebraic identity that states that a square plus b square minus 2 times ab equals to a minus b square that equals to 0. In our specific expression, a equals to x and b equals to 2 times square root of 3. According to this algebraic identity, a minus this expression, a square plus b square minus 2 times ab equals to a minus b square. Therefore, this expression equals to actually a minus b square. A equals to x and b equals to 2 times square root of 3. Therefore, a minus b square, it is actually x minus 2 times square root of 3 square that equals to 0 according to this algebraic identity. Here we will take a root out of this equation number 1, and we will get that x minus 2 times square root of 3 equals to 0 because of the fact that the square root of 0 is 0. We will add 2 times square root of 3 to this equation number 1, and we will get that x equals to 2 times square root of 3 units. So we found out that x equals to 2 times square root of 3 units, so we can write here that x equals to 2 times square root of 3 units. Here also x equals to 2 times square root of 3 units. X equals to 2 times square root of 3 units. And here also x equals to 2 times square root of 3 units. So we want to find out the area of quadrilateral ABCD. So the area of quadrilateral ABCD equals to the area of triangle ADB plus the area of triangle BDC, because of the fact that quadrilateral ABCD consists of exactly those two triangles. Therefore, the sum of the areas of those two triangles will be equal to the area of quadrilateral ABCD. So I write it down. The area of quadrilateral ABCD equals to the area of this triangle, triangle ADB, plus the area of this triangle, triangle BDC. I will repeat again. The area of quadrilateral ABCD equals to the area of triangle, the right triangle, it is not the right triangle, but it is the area of triangle ADB plus the area of triangle BDC. Because of the fact that quadrilateral ABCD consists of exactly those two triangles. Okay? In order to find out the area of triangle ADB, we will draw perpendicular from point D to AB. We will define the touching point of the perpendicular from point D to AB as point S. We will define line segment D as SH. It is the abbreviation for the height. So it is a perpendicular, therefore this angle equals to 90 degrees and this angle also equals to 90 degrees. So we will focus on the right triangle, triangle ADS. On the right triangle, triangle ADS, sinus 30 degrees equals to h over x, and x is 2 times square root of 3. I repeat again. In the right triangle, triangle ADS, sinus 30 degrees equals to h over 2 times square root of 3. We know that sine 30 degrees is 1 over 2, so I write it down. 1 over 2 equals to h over 2 times square root of 3 units. We will multiply this equation by 2 times square root of 3 units, and we will get that 2 times square root of 3 over 2 equals to h. 2 over 2 is 1. So we will get that h equals to square root of 3 units. So we found out that h equals to square root of 3 units. The height to the base AB of triangle ADB equals to square root of 3 units. Now we can easily find out the area of triangle ADB. The area of triangle ADB will be equal to the base of the triangle, that is actually AB, times the height to the base, that is h, over 2. The area of triangle ADB equals to the base of the triangle, that is actually AB, times the height to the base, that is h, over 2. We know that AB equals to 4 units. H equals to square root of 3 units. all divided by 2. So we found out that the area of triangle ADB equals to 4 times square root of 3 over 2. 4 over 2 is 2. So it is 2 times square root of 3 square units. So the area of triangle ADB equals to 2 times square root of 3 square units. And now we will find out the area of triangle BDC, this triangle. And we will find out the area of triangle BDC according to a special formula. First of all, we will find out the semi-perimeter of triangle BDC. The semi-perimeter of any triangle is equal to the perimeter of the triangle over 2. So the perimeter of triangle BDC is actually 2 plus 2 plus 2 times square root of 3 units. So the perimeter of triangle BDC equals to 2 plus 2 times square root of 3 units. And if we divide the perimeter by 2, we will get the semi-perimeter. So S equals to this expression over 2. That equals to 2 plus 2 is 4, plus 2 times square root of 3 over 2. 4 over 2 is 2, and 2 times square root of 3 over 2 is square root of 3. So we found out that the semi-perimeter of triangle BDC, that is S is the abbreviation for semi-perimeter, S equals to 2 plus square root of 3 units. And the area of triangle BDC equals to the square root of S times S minus A times S minus B times S minus C. We've already found out that S, the semi-perimeter of triangle BDC, equals to 2 plus square root of 3 units. And we know that A equals to 2 units, B equals to 2 units, and C equals to 2 times square root of 3 units. So we can put the data inside this equation and we'll get that square root S is 2 plus square root of 3 units. S minus A is 2 plus square root of 3 minus 2 is square root of 3. S minus B is also square root of 3 because A equals to B. And S minus C is 2 plus square root of 3 minus 2 times square root of 3. That is to say, it equals to 2 minus square root of 3 units. So here, square root of 3 times square root of 3 is 3. 2 plus square root of 3 times 2 minus square root of 3. We will calculate the value of this expression by using the algebraic identity that A plus B times A minus B equals to A square minus B square. Here A is 2, so A square is 4 minus b squared. B is square root of 3, so b squared is 3, so it is minus 3. So we got 4 minus 3 is 1, and 1 times 3 is 3. So we found out that the area of triangle BDC, it is actually square root of 3 square units, and the area of quadrilateral ABCD equals to the area of triangle ADB, that is actually 2 times square root of 3 square units, plus the area of triangle BDC. I'll repeat again, the area of triangle ADB equals to 2 times square root of 3 units, and we just right now found that the area of triangle BDC equals to square root of 3 square units, and 2 times square root of 3 units plus 1 times square root of 3 units is equal to 3 times square root of 3 units, or 3 square units. So the area of quadrilateral ABCD equals to either 3 times square root of 3 square units, or in terms of numbers, it equals to 5.196 square units. Okay, we finished with the second method. Now I will summarize the lecture. Actually, we wanted to find out the area of quadrilateral ABCD, and we found out the area of quadrilateral ABCD using 2 different methods. In the first method, we make a construction from point D. We do perpendicular to AB. So this again equals to 90 degrees, and this again equals to 90 degrees. And we define the touching point between the perpendicular from D to AB is point E. Then we focus on the right triangle, triangle ADE. On the right triangle, triangle ADE, sinus 30 degrees equals to DE over AD. Actually, we defined DE as A, that is to say DE equals to A units in its length. So DE equals to A, so we can substitute DE by A. So we got that sinus 30 degrees equals to A over AD. Sinus 30 degrees is 1 over 2. So we get that 1 over 2 equals to A over AD. We cross multiply the equation number 1, and we got that AD equals to 2 times A. AD equals to 2 times A. So we wrote here that AD equals to 2 times A. But because of the fact that it is given us in the question that AD equals to CB, and we also found out that AD equals to 2 units, we will derive from this equation that CB also equals to 2A. Here, CB equals to 2A. Then we drew perpendicular from point D to CB. We define the touching point between the perpendicular from D to CB as point F. Then, so you can see that quadrilateral DEFB has 3 right angles. 1, 2, 3. This angle equals to 90 degrees because it is given as the question. And the other 2 angles, they are equal to 90 degrees because we built it like that. According to our construction, and I presented to you rule number 1. According to rule number 1, the sum of the angles in any quadrilateral is equal to 360 degrees. So if we focus on quadrilateral DFEB, quadrilateral DFEB has 3 right angles. The sum of 3 right angles is 90 times 3 is 270 degrees. And we define the fourth angle as angle X. So in total the sum of those 4 angles must be equal to 360 degrees, that is to say 270 degrees plus the size of the fourth angle must be equal to 360 degrees according to rule number 1. We subtract the 270 degrees from this equation and we got that angle X equals to 360 degrees minus 270 degrees, that is to say it equals to 90 degrees. So we found out that angle X is a right angle. Therefore, we know that all the angles inside quadrilateral DFEB are right angles. They are equal to 90 degrees. And then I presented to you rule number 2. According to rule number 2, any quadrilateral that has 4 right angles must be at least a rectangle if not a square. And because of the fact that quadrilateral DFEB has 4 right angles, therefore according to rule number 2, quadrilateral DFEB is a rectangle. So we relate to quadrilateral DFEB as a rectangle. It is true according to rule number 2. Then I presented to you rule number 3. According to rule number 3, the opposite sides of a rectangle are equal to each other. That is to say, the opposite sides of rectangle DFEB are equal to each other. It means that DE equals to FB. According to rule number 3, DE equals to FB. But DE equals to A according to our definition. From this equation, we will derive that FB also equals to A. FB also equals to A. What is the value of CF? The value of CF, you can see it easily from the drawing, that it equals to CB minus FB. CF equals to CB minus FB, but CB equals to 2A, FB equals to A. So CF equals to 2A minus A, that is to say CF equals to A. So we found out that CF equals to A. Then we join together points D and B by a straight line, and we proved that those 2 triangles can go into each other. We actually proved that triangle DCF can go into triangle DFB. Why those 2 triangles can go into each other? First of all, CF equals to FB equals to A. CF equals to FB equals to A. Angle CFD equals to angle BFD equals to 90 degrees. Those 2 angles, they are both right angles, therefore they are equal to each other. DF is a common side, it belongs to both triangles, so DF or FD equals to FD equals, so it is a common side that belongs to both triangles. So we proved that triangle DCF congruent, this is the sign of congruent, to triangle BFD according to side angle side rule. And from the fact that those 2 triangles can go into each other, we will conclude that DC equals to BD according to the rule here. DC or CD equals to DB according to the rule that corresponding sides and congruent triangles are equal to each other. Those 2 triangles can go into each other. Therefore, the 2 corresponding sides, that is to say CD and DB, will be also equal to each other. But it is given us the question that CD equals to 2 units. CD equals to 2 units. So from this equation, we will derive that BD also equals, BD or DB equals to 2 units. So here, BD or DB equals to 2 units. Then I presented to you a new law, the law of cosines. What is the law of cosines? First of all, the law of cosines is true in any triangle. So if we have this triangle, triangle ABC, that could be any triangle, and we know that the length of AB is A units, the length of AC is C units, and the length of BC is B units, and the angle between AB and BC is theta. Then according to the law of cosines, A squared plus B squared minus 2 times AB times cosine theta equals to C squared. We subtracted C squared and also added 2 times AB cosine theta to this equation, and we got that A squared plus B squared minus C squared equals to 2 times AB. We divided this equation by 2 times AB, and we got that cosine theta equals to A squared plus B squared minus C squared over 2 times AB. We actually implemented the law of cosines in our triangle, that is actually triangle ADB. We know that AD equals to 2A, DB equals to 2, and AB equals to 4 units, and the angle DAB equals to 30 degrees. According to the law of cosines, cosine 30 degrees equals to 2A squared plus 4 squared minus 2 squared over 2 times 2A times 4. Cosine 30 degrees is square root of 3 over 2. 2A squared is 4A squared. 4 squared is 16, minus 2 squared is minus 4, so 16 minus 4 is 12. So in the numerator we have 4A squared plus 12, and in the denominator we have 2 times 4 is 8, and 8 times 2A is 16A. Then we multiply this equation by 16A, and we got the square root of 3 over 2 times 16A equals to 4A squared plus 12. Here 16 A over 2 is 8. So we got here in this side of the equation 8 times square root of 3 times A equals to 4A squared plus 12. Here we divided this equation by 4, and we got that 8 over 4 is 2. So here we have 2 times square root of 3 times A. 4 over 4 is 1, so here we will have A squared. 12 over 4 is 3, so in conclusion we got that 2 times square root of 3 times A equals to A squared plus 3. Then I subtracted 2 times square root of 3A from this equation, and we got that A squared plus 3 minus 2 times square root of 3 times A equals to 0. Here I substituted 3 by square root of 3 squared, and we got that A squared plus square root of 3 squared minus 2 times A times square root of 3 equals to 0. This expression is very similar to the algebraic identity that states that A squared plus B squared minus 2 times AB equals to A minus B squared, that equals to 0. In our specific expression, A equals to A and B equals to square root of 3 units. Therefore, A minus B, so according to this algebraic identity, A squared plus B squared minus 2 times AB equals to A minus B squared. So we can substitute this expression by A minus B squared. In our specific expression, A equals to A and B equals to square root of 3 squared, so A minus B squared equals to A minus square root of 3 squared, that equals to 0. We took a root out of this expression, and we got that A minus square root of 3 equals to 0, because the square root of 0 is 0. We added square root of 3 to this expression, and we found out that A equals to square root of 3 units. So here you can write down that A equals to square root of 3 units. Also here A equals to square root of 3 units. And also here A equals to square root of 3 units. Then we focused on triangle DEB. We implemented the Pythagoras theorem on the right triangle, triangle DEB. The square of the hypotenuse is equal to the sum of the squares of the perpendiculars according to the Pythagoras theorem. That is to say, DE squared plus EB squared equals to DB squared. DE equals to square root of 3. So DE square is square root of 3 squared. Square root of 3 squared is 3. EB is the missing variable, so EB square is EB square plus DB square. DB equals to 2, so DB square is 2 squared. 2 squared is 4. So we got it going into equation number 1, 3 plus EB square equals to 4. We subtracted 3 from this equation, equation number 1. And we got that EB square equals to 4 minus 3 is 1. EB square equals to 1. We took a root out of this equation, equation number 1, and we got that EB equals to square root of 1. The square root of 1 is 1, so we found out that EB equals to 1. EB equals to 1. And we also know that the opposite sides of a rectangle are equal to each other according to rule number 3. Therefore, EB equals to DF. But EB equals to 1, therefore DF will be also equal to 1. What is the value of AE? AE equals to AB minus AB. AE equals to AB minus EB. AB is 4 and EB is 1. So AE equals to 4 minus 1. That is to say AE equals to 3 units. Now we can easily find out the area of quadrilateral ABCD. Quadrilateral ABC consists of triangle ADE and also rectangle DFEB and also triangle DCF. Therefore, the sum of the areas of those 3 figures will be equal to the area of quadrilateral ABCD that consists those 3 figures. So the area of quadrilateral ABCD equals to the area of the right triangle ADE plus the area of rectangle DFEB plus the area of the right triangle CDF. The area of triangle ADE equals to the base of the triangle that is AE times the height to the base that is DE over 2. Okay, AE equals to 3. DE equals to square root of 3. So the area of triangle ADE equals to 3 times square root of 3 over 2. And the area of rectangle DFEB will be equal to the area of any rectangle is the width of the rectangle times the length of the rectangle. That is to say EB times FB. And here EB equals to 1 and FB equals to square root of 3. So the area of rectangle DFEB equals to square root of 3 square units. And then the area of the right triangle, triangle DFC equals to the base of the triangle that is actually DF times the height to the base that is CF over 2. DF equals to 1. CF equals to square root of 3 units. So DF times CF is 1 times square root of 3 all divided by 2. So we found out that the area of triangle CDF equals to square root of 3 over 2. Then we took a common factor square root of 3 from this out of these expressions. Inside the brackets, what is left from this expression? 3. What is left from this expression after we took square root of 3 as a common factor? What is left? It is actually 2. And what is left from this expression after we took square root of 3 as a common factor? What is left? It is actually 1. And then in the denominator, we have 2. So square root of 3. 3 plus 2 is 5. 5 plus 1 is 6. So we got the square root of 3 times 6 over 2 equals to the area of quadrilateral ABCD. 6 over 2 is 3, so we found out that the area of quadrilateral ABCD equals to either 3 times square root of 3 square units, so in terms of numbers, it equals to 5.196 square units. Okay, so we finished with the first method. Then I presented to you how to find out the area of quadrilateral ABCD using the second method. In the second method, we did another construction. From point C, we drew perpendicular to CB, that is to say this angle equals 90 degrees. And from point A, we drew perpendicular to AB, that is to say this angle equals to 90 degrees. And we defined the intersection point between the perpendicular from A and the perpendicular from C as point E. And then actually here we created two right angles by drawing two perpendiculars, and this angle is right angle because it is given us the question. So quadrilateral ABCE is 3 right angles, and the sum of 3 right angles is 270 degrees, plus the size of the fourth angle that is defined as angle X. The sum of those 4 angles must be equal to 360 degrees according to rule number 1. We subtracted 270 degrees from this equation, and we got that angle X equals to 360 degrees minus 270 degrees. That is to say angle X equals to 90 degrees. So actually, as you can see, this angle equals to 90 degrees. Therefore, quadrilateral ABCE is 4 right angles. And according to rule number 2, any quadrilateral that has 4 right angles must be at least a rectangle. So we will relate to quadrilateral ABCE as a rectangle. Then we have rule number 3 that states that the opposite sides of a rectangle are equal to each other. So the opposite sides of rectangle ABCE will be equal to each other. That is to say AB equals to CE. AB equals to CE according to rule number 3, but we know that AB equals to 4 units. It is given us the question. From this equation we will derive that CE also equals to 4 units. CE equals to 4 units. Likewise, according to rule number 3, AE equals to CB. AE equals to CB, and if we define CB as X, then from this equation we will derive that AE also equals to X. So CB equals to X and EA also equals to X. But we know it is given us the question that CB equals to AD. But CB equals to X according to our definition. From this equation we will derive that AD also equals to X. AD equals to X. Then we connected together points E and D by a straight line, and we connected together points D and B by a straight line. It is given us in the question that angle DAB equals to 30 degrees. By doing our construction, we created angle EAB, that is a right angle. This is a right angle. So 90 degrees minus 30 degrees will be the side of this angle. That is to say angle EAD will be equal to 90 degrees minus 30 degrees. That is to say angle EAD equals to 60 degrees. And we know that those two sides also equal to each other. They are both equal to X. So I drew triangle ADE in a new page, and we analyzed triangle ADE. We have triangle ADE. We know that AD equals to AE equals to X. Angle EAD equals to 60 degrees. And we have the rule that in front of equal sides in the triangle there are equal angles. That is to say, in front of those two equal sides, we have those two angles that also must be equal to each other. So if this angle is Y, this angle must be also equal to Y. And we know that the sum of the angles in any triangle is equal to 180 degrees. That is to say, Y plus the size of this angle, that is 60 degrees, must be equal to 180 degrees. Y plus Y is 2Y. 180 degrees. We subtracted 60 degrees from this equation, and we got that 2y equals to 180 degrees. We divided this equation by 2, and we got that angle y equals to 60 degrees. So this angle equals to 60 degrees, and this angle also equals to 60 degrees. Therefore, triangle ADE is an equilateral triangle, and we know that all the sides of the equilateral triangle are equal to each other. Therefore, DE will be also equal to x. So we can also write here that ED equals to x, this angle equals to 60 degrees, and this angle equals to 60 degrees. So this angle equals to 60 degrees. We found out that angle AEC is a right angle. That is to say it equals to 90 degrees. So 90 degrees minus 60 degrees will be the size of angle CED. That is to say angle CED equals to 30 degrees. Then we proved that those two triangles can go into each other. So why those two triangles can go into each other, triangle A or B, can go into triangle CDE. Why they can go into each other? First of all, AB equals to CE equals to 4 units. AB equals to CE equals to 4 units. Angle BAD equals to angle DEC equals to 30 degrees. Those two angles are both equal to 30 degrees, therefore they are equal to each other. AD equals to ED equals to X. AD equals to ED equals to X. So we actually proved that triangle AOB can go into triangle EDC according to side angle side rule. From the fact that those two triangles can go into each other, we will conclude that DC equals to CB, DC equals to CB. But it is given us the question that CD equals to 2 units. CD equals to 2 units. From this equation, we will derive that DB also equals to 2 units. DB equals to 2 units. Then we implemented the law of cosines on triangle ADB. So I drew triangle ADB in a new page, and we implemented the law of cosines on this triangle. So this is triangle ADB. AD equals to X, DB equals to 2, and AB equals to 4 units. Angle BAD equals to 30 degrees. According to the law of cosines, cosine 30 degrees equals to x squared plus 4 squared minus 2 squared over 2 times x times 4. Cosine 30 degrees is square root of 3 over 2. X squared plus 4 squared is 16. Minus 2 squared is minus 4. 16 minus 4 is 12. So in the numerator we have x squared plus 12. In the denominator we have 2 times 4 is 8. 8 times x is 8x. So in the denominator we have 8x. We multiplied this equation by 8x. So we got that square root of 3 over 2 times 8x equals to x squared plus 12. 8 over 2 is 4. So in this side of the equation we have 4 times square root of 3x equals to x squared plus 12. Here we subtracted 4 times square root of 3x from this equation, and we got that x squared minus 12, x squared plus 12 minus 4 times square root of 3x equals to 0. Then we substituted 12 by 2 times square root of 3 squared because of the fact that 12 equals to 2 times square root of 3 squared. So we can do it. Here, so we got that x squared plus 2 times square root of 3 squared, that is 12, minus 2 times x times 2 times square root of 3 equals to 0. This expression is very similar to the algebraic identity that states that a squared plus b squared minus 2 times ab equals to a minus b squared, that equals to 0. In our specific expression, a equals to x and b equals to 2 times square root of 3 units. So according to this algebraic identity, this expression equals to a minus b squared. And a equals to x, b equals to 2 times square root of 3. So a minus b squared, it is actually x minus 2 times square root of 3 squared, that equals to 0. We took a root out of this equation, equation number 1, and we got that x minus 2 times square root of 3 square equals to 0. We added 2 times square root of 3 to this expression, and we got that x equals to 2 times square root of 3 units. So we can write here that x equals to 2 times square root of 3 units, or x equals to 2 times square root of 3 units, and also here x equals to 2 times square root of 3 units. Then we can easily find out the area of quadrilateral ABCD that consists of two triangles, triangle ADB and triangle BCD. The area of quadrilateral ABCD will be equal to the area of triangle ADB plus the area of triangle BCD that it consists of. The area of quadrilateral ABCD equals to the area of triangle ADB plus the area of triangle BDC. Here, in order to find out the area of triangle ADB, we will calculate the height. We draw perpendicular from point D to AB, so this angle equals to 90 degrees, this angle equals to 90 degrees. We define the touching point between the perpendicular from D to AB is point S. In triangle ADS, sin 30 degrees equals to edge over x, what x is 2 times square root of 3. So in triangle ADS, sin 30 degrees equals to edge over 2 times square root of 3. Sin 30 degrees equals to 1 over 2. So 1 over 2 equals to edge over 2 times square root of 3. We multiply this equation by 2 times square root of 3, and we got that angle x equals to 2 times square root of 3 over 2. 2 over 2 is 1. So we found out that the height of triangle ADB is square root of 3 units. Now we can easily find out the area of triangle ADB. The area of triangle ADB equals to the base of the triangle, that is AB, times the height, that is edge, over 2. The area of triangle ADB equals to the base, that is AB, times the height, edge, over 2. AB equals to 4, edge equals to square root of 3, all divided by 2. So the area of triangle ADB equals to 2 times square root of 3 square units. Then we found out the area of this triangle TBC by using a special formula. The area of triangle DBC, first of all, we found the semi-perimeter of triangle DBC. The semi-perimeter of triangle DBC equals to the perimeter over 2. So the perimeter of triangle DBC is 2 plus 2 plus 2 times square root of 3. That is the sum of its sides. By dividing by 2, we get the semi-perimeter, that is actually 4 plus 2 times square root of 2 over 2. 4 over 2 is 2. 2 times square root of 3 over 2 is square root of 3. So we found out that the semi-perimeter of triangle DBC equals to 2 plus square root of 3 units. And the area of triangle DBC equals to the square root of S times S minus A times S minus B times S minus C. S is the semi-perimeter, A, B, and C are the length of the sides of the triangle. A equals to 2, B equals to 2, and C equals to 2 times square root of 3 units. So we put the data inside this equation, and we got that the area of triangle DBC equals to S is 2 plus square root of 3. S minus A is square root of 3, S minus B is square root of 3, and S minus C is 2 minus square root of 3. Square root of 3 times square root of 3 is 3. 2 plus square root of 3 times 2 minus square root of 3 is 4 minus 3. 4 minus 3 is 1. So 1 times 3 is 3. So the area of triangle BDC is square root of 3 square units, and the area of quadrilateral ABC equals to the area of triangle ADB plus the area of triangle BDC. The area of triangle ADB is 2 times square root of 3 square units, and the area of triangle BDC is square root of 3 units. So the area of quadrilateral ABC equals to 2 times square root of 3 units plus 1 times square root of 3 units. That is to say, the area of quadrilateral ABCD equals to either 3 times square root of 3 square units, or in terms of numbers, it equals to 5.196 square units. So in both methods, we found out that the area of quadrilateral ABCD equals to either 3 times square root of 3 units, so in terms of numbers it equals to 5.196 square units. Okay, thank you very much.